Chapter 5, Water for Life, Part 4. We're going to talk about protecting our drinking water, water treatment, and water solutions for global challenges in this final lecture for Chapter 5. In 1974, the decade when really a lot of environmental regulations were passed and a lot of awareness regarding the environment began, the Safe Drinking Water Act was legislated. What the Safe Drinking Water Act does is determine the amount of contaminants in water that are allowable using what we discussed in Chapter 0 regarding risk assessment. So they did risk assessment on various pollutants and determined maximum levels. Now there are two terms used for these levels. Maximum contaminant level goal, MCLG, which very frequently is 0. And there is another term called maximum contaminant level that is a minimum based on risk assessment, where if it goes above that minimum concentration, then action is necessary in order to remedy the pollutant level. These concentrations are frequently expressed in parts per million or parts per billion, and they're determined based on just an average body weight and consumption of water, tap water, throughout their lifetime. So here are some examples of contaminants, the levels, and the level goals. As you can see, most of the level goals are 0. Lead may vary slightly due to natural deposits and piping, as well as nitrates. There are natural deposits of nitrates. It would be great if we could see a level of goal of 0 for all of these, but in some cases it's just not possible. But here we have, in terms of the maximum level before action is taken, we have these values here in ppm. Lead and cadmium, chromium, these are heavy metals, toxic metals. We'll talk about these trihalomethanes in a moment. Let's take a look at nitrate pollution or nitrogen-based pollution. So you can see the areas of nitrogen or nitrate type contamination are largely centered on the more farm-based states. You see here in California, in the Central Valley, where a lot of farming occurs, we have high nitrogen inputs, a lot of runoff, which could potentially contaminate groundwater and aquifers. It's actually a problem for rural areas in particular that use groundwater or well water exclusively. They really should be testing their water regularly, and they may need to install a filtration device in order to prevent high levels of nitrates ending up in their drinking water. Let's see how municipalities treat their water before it makes it into your home. I'd like to expand a little bit more on chlorination. So at the water treatment plants, during the final stages, chlorine is bubbled through the water in order to obtain a certain concentration known to kill any residual bacteria. Sometimes it's also added as a hypochlorite solution. And these hypochlorite ions also kill microbes. So chlorine gas actually will form this hypochlorite ion, or they can add the hypochlorite ion directly. Trihalomethanes are one of the negative byproducts of chlorination. Also, if there's any bromine or iodine contaminants in the water, they can combine with organic compounds and form these trihalomethanes. Chloroform is one of them. Bromoform is another one if it reacts with bromine. They are carcinogenic, and they're limited in total concentration to 80 parts per billion. However, the number of trihalomethanes and dihalomethanes and other organic contaminants are not always monitored. There are many different byproducts. So some municipalities and also in Europe are thinking about trying to move away from chlorination. Although chlorination of water saves countless lives every year. So you have to look at that. Before chlorination of water, many, many more people died of dysentery and other bacteria-causing illnesses from contaminated water. Ozonation is being tried in the UK. It's effective and relatively harmless because that ozone just breaks down into oxygen, but it is more expensive. So that's the main reason it's not being used extensively now. Those hydroxyl radicals will basically kill microbes. UV radiation is also being tried in the UK and some water districts. Essentially, shining UV light of a particular frequency will kill bacteria. Just as UV light is dangerous to us, it is very dangerous to microbes. Thinker buddy question. Which set of steps is most typical of municipal drinking water purification in the U.S.? A. Ozonation, distillation, chlorination. B. Flocculation, filtration, chlorination. C. Ultraviolet light, ion exchange, filtration. Or D. Distillation, chlorination, ozonation. B is correct. First you have that flocculation chamber settling out those larger particles. Then you run it through a filtration stage to remove out the smaller particles. Then finally you sterilize the water with chlorine. Which is true concerning chlorine molecules in water? A. Chlorine serves as an inexpensive, easily delivered, and persistent antibacterial in water. B. Chlorine reacts with the small, naturally occurring molecules in water to form halogenated organics. C. Chloroform and ozone are alternatives in current use as antimicrobial agents in water. Or D. Statement A and B are both true. D is correct. Chlorine is an inexpensive and extremely effective way of preventing microbes from contaminating tap water. It also, however, can produce small amounts of these halogenated organics, which are cancer causing. But again, the levels of those compounds are very, very small. If you are concerned, you may want to consider getting a carbon filter and filtering any tap water that you drink. There's a number of ways to make fresh water from salt water. That is particularly important to countries in very warm areas without an adequate supply of fresh water. Desalination is the process of removing ions from salt water, essentially the salt, desal, sal referring to salt, desalination, removing salt from water. Distillation is one way this can be achieved. We mentioned distillation before. You're essentially boiling the salt water. The water without the ions collects in the condensing chamber and then is collected. And there are other ones, solar powered distillation devices that are also in existence. Reverse osmosis is a process that uses pressure to force the water through a semi-permeable membrane. What happens is the water molecules are able to pass through the membrane, but the ions and other impurities in the water are not able to pass through. This is also a fairly expensive way to purify water. There are reverse osmosis plants being constructed in existence in a number of Middle Eastern countries on the coast. Another method is the life straw. It was created recently, relatively, And it is a filtration device that can be used over and over again, which removes bacteria, viruses, parasites. I'm not sure if it removes organic compounds, but it basically saves, again, many, many lives due to waterborne illnesses. This ends the fourth and final part of Chapter 5.